All right, welcome back. This is Mr. Spencer on your Stat Sensei, and we're going to be doing chi-square test of homogeneity. And every year, my students ask, what happens if the expected counts are not big enough? Because that's one of the conditions. Expected counts must be greater than 5 for a chi-square test. And as it turns out, you can fix it. And we're going to do this example. It's not shown up on an AP exam, but we're going to do this example here. So surveys, and they tell me that, it's like, oh, we have multiple samples. If I have multiple samples, I'm thinking this is a chi-square test of homogeneity right there because of the multiple samples of drivers of differing age groups were taken to determine if the driver had been in an accident during the previous year. And so was it a minor or major accident? The results are tabulated below. So normally we would just go this times this divided by that. And so we'd plug that into the table, into the matrix. So we have 1, 2, 3, 4, 5, 1, 2, 3. So this is a 5 by 3 matrix. So I'm going to go ahead and take a moment. It's going to take a little bit of time. But I'm going to enter that data. Here's how you go. You're going to go second, followed by matrix, edit, 5, enter, 3, enter. And we're going to start inputting. So 67, enter, 10, enter, 5, enter, 42, enter, 6, enter, 5, enter, 75, enter, 8, enter, 6, enter, 56, enter, 4, enter, 6, enter, 57, enter, 15, enter, 1, enter. All right, so I've entered the data. I'm going to go ahead and run the test, which I know is a little bit odd. Stat test, chi-squared test, and calculate. Well, I end up with this value, but I'm going to go back because I'm going to let you know real quickly that we have a problem here. All right, and degrees of freedom, well, I'm going to talk about that. Would be degrees of freedom would be 5 minus 1 times 3 minus 1. So that's where the 8 came from. All right, so let's go back because we know we have, I'm telling you we have a problem. So second matrix, we're going to go to edit and we're going to look at matrix B. And when I look at, remember, all my counts have to be greater than 5 or greater. And I have several right here that are not. So I have a problem. So what do? Well, you can actually combine categories. So what if I combine instead of under 18, I made it under 25, instead of over 65, I made it over 40. So I combined those. The 42 and the 67 gave me 109, this gave me 16, and this gave me 10. So I'm going to rerun this, and I'm going to rerun this as we have 1, 2, 3, 1, 2, 3. This is now a 3 by 3 matrix. So I'm going to go back and rerun this. And again, this has not happened before on the AP exam, but students asked me about it, so I put it in here. So second matrix, over to edit, press enter, 3 by 3. So we have 109, 16, and 10. 75, 8, 4, 113, 119, enter. Oops, excuse me, not 119, 19, enter, and 7, enter. All right. Now my observed counts don't have to be greater than 5, but my expected counts do. So let's see if that fixed our problem or whether we have to collapse some more. So stat test, chi-square test. All right. And I end up getting a pretty big p-value and a small chi-squared. So chi-squared equals 2.07, p equals 0.722. So let's go back and check. Second matrix, edit. And it looks like my smallest expected value is 5.06, which is right here. So all of them are large enough, okay? So let's run this test. No, the proportion of accident types is the same for each category. By the way, we want to make sure we're using the word proportion. The proportion of accident type is not the same for each category, all right? Conditions, independent random samples. Well, they told us we had random samples. We have to assume that those are surveyed. We know we have random samples. N is less than 10%. Technically, I should be combining these. So this should be, instead of 670, I should combine those two and it'd be under the age of 25, how many are there? So, and I'm assuming that there's plenty under the age of 25, plenty in the 26 to 40 category, and plenty in the over 40 category, if we added all those up. So there's plenty of them, so I'm not going to worry too much about it, but you do need to do it for each group, okay? So then when I go to my observed minus expected, I always look at the first one and I always look at the last one. So I'm going to be looking at this and this. So 109 minus 111, observed minus expected, that's squared divided by the 111. And that's what I have here, plus dot, 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 then 19 minus 16.56, excuse me, 7 minus 8.09. I didn't go to the last one. I should be looking at that one. 7 minus 8.09 squared divided by 8.09 gives me 2.073. So there's my chi-squared value. So my p-value is greater than 0.05. We failed to reject. There is not sufficient evidence that alpha equal 0.05 to suggest the proportion of accident type is not the same. Proportion of accident type is the same, right? We cannot reject the null. So we're basically having to believe that it is the same for each category. We didn't prove that, but that's what we conclude because we cannot say that it is different. We're unable to say that it's different, okay? By the way, if you don't like saying they're not the same, you can sit there and say is different for each group, right? All right, thank you for watching and we'll do another one. Hope to see you there.